People have always wanted a third eye, a way to pierce the veil of uncertainty and foresee what comes next. From ancient oracles to modern data scientists, the desire is the same, but predicting the future is not magic. It is a skill, a mix of probabilistic reasoning, pattern recognition, models, and disciplined experimentation. In this episode, we'll examine what science actually says about forecasting, when humans are good at it, where we fail, practical methods to improve predictions, and a hands-on experiment you can run over the next 30 days to sharpen your predictive sense. Let's begin with a simple but crucial distinction: prediction versus prophecy. A prophecy claims absolute certainty about a single, unique future. Scientific forecasting, in contrast, deals in probabilities, carefully calibrated degrees of belief that particular outcomes will happen. Good forecasters don't say this will happen. They assign numbers. A 20% chance, a 70% chance. This language forces clarity and intellectual honesty. That probabilistic mindset is the foundation of all reliable prediction. Next, understand base rates. The single biggest mistake non-experts make is succumbing to the inside view, focusing only on the unique details of a specific case while ignoring the outside view, the base rate information of how often an event typically happens. If you ask whether a new startup will succeed, don't just focus on the charismatic founder. Start with the base rate for startups in that market, then adjust for specific signals. Forecasters who anchor on base rates outperform those who rely on gut feelings alone. Closely tied to base rates is the concept of signal and noise. Some cues in the world carry predictive signal, others are random noise. Good forecasting is mostly about separating the two. For example, noticing that a company's user growth is steady is a signal. A viral one-day spike is likely noise unless it persists. Training your eye to ask, is this a repeatable pattern or a one-off, is a practical habit. Now let's talk about the cognitive biases that sabotage prediction. Confirmation bias makes us overweight evidence that fits our prior hypothesis. The availability heuristic makes us overestimate the likelihood of dramatic, easily recalled events. Overconfidence leads people to give 90% probability to events that actually occur only 60% of the time. The planning fallacy makes us underestimate time and cost. The antidote is explicit calibration. Track your own probability estimates and compare them to outcomes. Good forecasters keep a log of predictions and update their estimation process when they're off. There is measurable skill in forecasting. Research from forecasting tournaments, including the Good Judgment Project, shows that some people, super forecasters, consistently outperform others. What makes them better isn't genius. It's a set of cultivated habits. They are intellectually humble, always aware they might be wrong. They break problems into parts, update estimates frequently with new data, stay open to revision, and combine diverse information sources. They think in ranges, not absolutes, and they aggregate evidence with discipline. Tools improve predictions. Simple Bayesian updating is a framework. Start with a prior probability, collect evidence, and update toward a posterior. In practice, that can mean estimate a prior chance for an outcome, note new indicators, and adjust incrementally. Another tool is ensemble thinking. Combine multiple independent forecasts or models. Aggregation often beats single experts because errors cancel out. Prediction markets and structured judgment systems are powerful because they pool information. Markets where people buy and sell shares representing outcomes convert dispersed beliefs into prices that reflect collective probability. Similarly, Delphi-style expert rounds, where experts revise anonymously in light of group feedback, produce better calibrated forecasts than unstructured panels. Pattern recognition and intuition do have a place, but their reliability depends entirely on the environment. Psychologists call these kind learning environments, where patterns are stable and feedback is rapid and clear. Chess masters or firefighters develop accurate intuition because they operate in such domains, with thousands of immediate feedback cycles. But many real-world problems, like political or economic forecasting, are wicked environments where rules change and feedback is delayed or ambiguous. Here, intuition without structure leads to systematic error. So how do you train predictive skill? First, keep a forecasting journal. For each question you want to predict, write a probabilistic estimate and the reasoning behind it. Revisit results later and score yourself. Common scoring rules like Breyer scores quantify calibration and sharpness. Second, Break complex predictions into sub-questions. Instead of forecasting whether a new law will pass, estimate the votes in committee, the lobbying intensity, and the media coverage. Smaller sub-questions are easier to update and combine. Third, practice active open-mindedness. Seek disconfirming evidence deliberately. Ask, what would prove me wrong? This habit is a direct countermeasure to motivated reasoning. Our tendency to find arguments we want andade de dens to ber order, darin sperm doben stop be plata bervey. It reduces overconfidence and forces you to consider alternative paths. Fourth, use outside views. Compare your case to similar historical analogs. For instance, when evaluating a product launch, compare to launches with similar budgets, distribution channels, and competitive environments. Fifth, set explicit decision thresholds. If you need to act only when probability crosses 70%, make that rule clear. Thresholds prevent spinning forever and help translate forecast into action. Sixth, diversify models. Use qualitative judgment, simple statistical models, and where possible, machine learning signals. Each approach has different failure modes. Together, they provide balance. What about gut feelings or so-called intuition techniques like trusting your first impression? These can be useful in domains with tight feedback loops and stable structure. But for messy, social, or geopolitical forecasting, the scientific approach is superior. Quantify uncertainty, update, and aggregate. Now let's cover a few practical forecasting methods you can adopt today. 1. The pre-mortem. Before you make a decision, imagine it failed spectacularly and list plausible reasons. Pre-mortems surface hidden risks and improve planning. 2. Reference class forecasting. Find a class of past similar cases and use their outcomes as a guide. 3. Red teaming. Deliberately appoint someone or a subgroup to argue against your forecast. 4. Rapid small bets. Instead of big all-or-nothing bets, make many low-cost experiments that reveal signal. For product teams, that might mean A/B tests. For personal decisions, it might mean short trials. 5. Calibration training. There are online tools that give practice with probability questions and show your Breyer score. Regular practice improves calibration. Let's illustrate with a concrete example. Suppose you want to predict whether a local cafe will succeed in its first year. A gut feeling is unreliable. Instead, start with the base rate. What percentage of small food businesses fail in the first year? Then, break the problem down. Location foot traffic, owner experience, local competition, online reviews, and capital reserves. You can gather real data for these, count pedestrians, check the owner's LinkedIn, analyze Google Maps for competitors, and scrape early Yelp reviews. This structured approach produces a far more robust estimate than a single gut call. A note on ethical forecasting: predicting the future carries responsibility. Forecasters must be transparent about uncertainty and avoid overclaiming. When people act on your forecasts, as in finance or public policy, poor communication can cause real harm. But the responsibility also lies with us as consumers of forecasts, to demand probabilistic language and question claims of certainty. Use probability rather than slogans, and always document assumptions. Now I'll give you a practical 30-day training plan to improve your forecasting and intuition. Day 1-3, start a forecasting journal. Pick 5 questions you care about this month and assign probabilities to each. Day 4-10. Break each question into 2 to 4 sub-questions and gather relevant base rate data each day. Day 11 to 17, run 3 quick small bets or experiments related to one question. Collect results and log learnings. Day 18 to 23, practice calibration training exercises online for 15 minutes daily. Keep your Breyer score. Day 24-27, do a pre-mortem for a planned decision and list mitigations. Day 28 to 30, aggregate results, reflect on where you were overconfident or underconfident, and plan the next 30 days with adjusted priors. Finally, limits. Some futures are inherently chaotic and unpredictable at long horizons. Weather beyond 2 weeks and complex geopolitical chains can be noisy. Acknowledging limits prevents false confidence, but for many personal, business, and policy questions, probabilistic thinking, calibration, and disciplined updating markedly improve outcomes. In short, the third eye is not supernatural, it's exgayan. It's mawandero. Is mom and siu zatsur adilda browal. Say dewayat. Start with base rates, separate signal from noise, use probabilistic estimates, update with new evidence, break problems down, and practice calibration. Over time, small habits compound. Predicting the future better is less about certainty and more about making smarter bets and learning quickly when you're wrong. Thanks for watching. Subscribe for more evidence-first tools to think and decide better.